Hey, this is Sean at Heifer Ranch, and today we're going to be talking about our DIY walk-in cooler. In the gardens, keeping the produce cold and fresh is super important for the sale of fresh vegetables. We have had a little walk-in cooler that's about 8 feet by 8 feet, and we really quickly outgrew that space as we started to scale. So we needed a bigger walk-in cooler, and we actually landed on using a shipping container. Shipping containers like this you can get online if you just Google used shipping containers. They're called like single-use containers. They've made the journey to bring products overseas and then they've outlived their life cycle. So the unit that we got is a used reefer unit, which is refrigerator freezer. So the refrigeration components don't work at all. And for us, that's not a problem because we're going to find a way around that. But it knocked off a huge amount off the price of the machine. For one that is working, could be as high as like $20,000. For one that's not working at all, could be about $9,000, which is what this one costs. Those kind of components aren't really meant to just run nonstop for years and years and years, the way that we're gonna use this cooler. And then also, there's only very few people that can repair that kind of stuff. So that was another reason why we went with the Coolbots, which I'll explain here in a little bit. So the $9,000 for this unit includes the cost of delivery. So it was the most affordable option for us and actually gave us the most space per dollar invested. It's 8 feet wide, 8 feet tall, and 40 feet long. You know, that's 5 times the size of our current walk-in cooler. All you have to do is just lift this handle and then push that around. And then once those little teeth at the top and the bottom are clear, it should just open right up. Yeah, so welcome to the inside of the cooler. You can see right off the bat, it doesn't look like a standard shipping container because it doesn't have that kind of corrugated metal. It exists, but it's behind these washable steel plates and behind the insulation. That's really great because it makes this super washable. So the floor is raised and slatted, and that allows water and debris to fall down, and so it can be washed out really easily. So we could bring a pressure washer in and pressure wash every single surface, even the ceiling and even the lights, which are vapor proof. So this is the brains of the operation, the guts of the operation, a standard window unit. Then this is the Coolbot unit. So we are using Coolbot Pro. Coolbot Pro actually allows you to talk to Wi-Fi, so you can monitor the temperature from your phone, which is really nice. So what the Coolbot does is really neat. It tricks the AC unit into running as a refrigerator. So the air coming out of a standard AC unit is really close to freezing. But if they just continuously ran at that temperature, they would freeze up really quickly. So what this does is it's a microcontroller that tricks it into thinking it's warmer than it is. So this is a little heating element, tricking it to thinking that it's hotter, so it runs harder. This temperature gauge right here that's in between the coils can tell when it's about to freeze up. It tells the machine to back off, basically. That way it never ices up. So it's always running as hard as it can without freezing up. It does take a little bit of the life off the machines, but most of our AC units are lasting like 4 and 5 years. Temperature can be adjusted here, and then it measures the temperature of the room and then adjusts everything accordingly. But keeping track of this temperature is really important if it's getting too warm in here and you don't want to have loss of your crops. But also if it gets too cold in here too, which won't really happen from the AC units, but this past winter we had an Arctic blast and it got down to -3 outside. So that would drop the temperature in here below freezing, which would have destroyed all of our produce. So what I did in order to get the cooler in is I first drilled holes where I wanted the cooler to go. So I drilled holes all the way through, and then I used power shears, and then I used a bread knife basically to cut the foam. But I tried not to use an angle grinder, which is typically how people cut standard shipping containers because they put off so much heat. And I believe the insulation inside the walls is flame retardant, but I didn't want to take that chance of lighting my shipping container on fire. So based on the AC unit, we had to use 210 power and then 120 for the Coolbot unit. So in order to get power to the unit, we did have to trench a line underground from a nearby building. We had to make sure that there was enough service to that building in order to pull off enough amperage to our unit. If we would have gone with the actual functional unit, it takes a lot of stuff that most houses and farms do not have. So that was already kind of another reason why we ruled out using a functional unit. It'd be cheaper, It applies to more farms. So on the back of our unit, it has its own electrical box and its own breakers for each AC unit. And so that way, if we need to work on one or replace one, we can turn off the breaker and safely change out an AC unit. So far, the AC units that we use have been running nonstop for at least 2 years now and have kept it about 40 degrees or cooler even through the peak of summer. The 2 AC units have worked pretty well for this whole space, but we are going to go ahead and add a third, and that'll allow us to actually partition the shipping container so we can have the front side will be 50 degrees, which is great for like tomatoes, winter squash, potatoes, and then go through a door, and then the whole back section will be 35 degrees for carrots, beets, lettuces, things like that. So for the outside of the cooler, we did make a couple of modifications, and there's a couple other considerations that you need to have when deciding kind of where to put this. One is distance to your field. You don't want to put it at the very back of your property like we did and have to go back and forth a lot. We poured gravel here to where we walk up onto gravel. We're not stepping down into standing water and then walking back into the cooler. And then also its proximity to livestock. You wouldn't want to put it in an area where there's high traffic or where the cattle graze around it, and then you step in where the cows have been and then step into the cooler. So those are some kind of considerations for siting. So that was the $9,000 for the unit, $1,000 for each AC unit and its Coolbot unit that goes with it. So there's 3 of those. I think it was $1,000 for the electrical work. So total cost was about $13,000. For us, we're storing as much as 30,000 pounds of vegetables through the winter, and this was a great fit for that. That's from our 3 acres of certified organic vegetables. We're producing year-round, so there is a lot of crops that are coming in and out of the field and need to be stored regularly. If you want to keep in mind where you want your farm to go and how you want to scale, it is worth, I think, getting the size that you're going to grow into. I think if you were like 5 acres, this is definitely where you'd want to be. Hey, thanks for watching. Please like and subscribe if you've enjoyed the content, and check out some of our other videos about a DIY root washer, as well as a guide to selecting a high tunnel. If you need name suggestions for naming your walk-in cooler, may I suggest the Christopher walk-in or the Stone Cold Steve walk-in?